So my today's project is image classification using CNN, that is convolutional neural network. The project objective is to classify images through convolutional neural network, detecting crack through machine learning model. Actually, I have collected around total 239 images near to the Lamar University. So here today I'm gonna detect the crack and uncrack through machine learning model. Here I have used total 15 epochs and the base number is 2. So here first we will show here see here the libraries and the setup. So first I import here TensorFlow, TF, OS, and here the data directory. I put the data in my computer. Here is the directory. So after loading that, we can see data is ready over here data. So the next is data loading. So if I load the data, we can see here the data matrix. The data actually it's converted into float 32. The images converted into float 32. Here is the data matrix. After running these code, we can see here like I have run matplotlib, numpy, and these data. So and here is my data direction. And after that data, once data load, I put here number 4. So per page, the 4 images will be loaded. Here we can see the images. These are loading from the my folder over here. And one thing I need to mention that is I created a folder here. The data that is crack and uncrack, I put all uh, images over here so that I can train my model, machine learning model over here through this model. And then this is the data scaling. I scaled the data. I divided this by 255, so it would be much way faster to scale and to convert the data to convert all the images here. And for data splitting, I use train size. These are my data size. That yeah, we can see here other different images are being loaded over here as I after running this code. And the total data we will train I trained here like trained validation and test in these 3 categories. So once I wrote the code over here, the model will be learned. And here I will build my deep learning model. So for building that, I first run here TensorFlow, Keras, import sequential, and then convo 2D max pooling, density, flatten, dropout, then image processing, image generator, image RMS prop, and here is model sequential, and here is the model here is the relo function, and 256 is the input shape. Here I found it here, so we need to write this over here. And then I write a model compile add-on function to run and model summary. So here we after running this, we can see my model summary. I convert to the none 250 total 448 program max polling 0. If I go to the next, here we can see the total summary. Total trainable program is like near to 3.6 million, and trainable program is all of those, and non-trainable zero. So here I already building my deep learning neural network for this project. After that, now I'm going to train my model. So for training my model here, I need to put the batch size. Here I can see our batch size is 2. We can see from there. And here is my data folder. Target size 256, 256, and epochs 15 epoch. Total I have used here. And I also used callback function. So total 15 epochs. Uh, and here after running these, we can see after running 15 epochs here, my accuracy, model accuracy is almost 97%. That is really good. Over everything over is more than 90%. That means my model is gonna run really good. And so here I will use the plotting. Uh, so we can see data loss from here. How and evaluate. We can actually evaluate the data from here, and there is a test. So when I'm gonna test my, so I loaded my all images in this folder, total 239 images. So I can randomly write any of the image number to see how it's gonna detect. So and I wrote here like predicted classes uncorrect or correct, it will actually show. So when I give input my model to identify whether the number 10 image is correct or incorrect, and after running this it's showing me that the class is predicted class is correct. As I written here, predicted class is correct or incorrect. And from here we can see here there is a crack in the image, so my model is uh, accurately giving me the result. We can see the result accuracy is more than 90% here. So I'm gonna check some more images. uh, so here I write down the 230 number images, and the model accuracy is 100%. We can see predicted class is uncorrect. There is I'm not seeing any kind of crack here. So it is 100% accurate my model here. And then I wrote 122. So here is correct, and the predicted class is correct. We can see from here. So here the accuracy is more than 93%. Still is okay. And the next image 198. I actually randomly select some image to see check. Pretty class is uncorrect. Here is uncorrect. We can see from here. And error validation data accuracy is 100%. That is really good. And here I put another image number 74. The predicted class is correct, and here is also correct. So this is the model actually does it looks, and it 100% giving me the accurate result. So how does we can actually check whether our model is gonna work accurately or not. So here it works perfectly. And if I look at my, so this is my total model here. If I show how model is here, and here we see the total trainable model. So this is my project.